Alright, today we're looking at section 3.5, and our target is I can solve systems of linear equations in two variables. Okay, so the type of thing that we're looking at would be something like this. 2x plus 3y equals 13, and x minus y equals 9. So that is an example of a system of two equations in two variables. Okay, now if each one of these actually represents a line, and so first thing we have to figure out is, if I graph these, what are the different things that could happen? Okay, so if I graphed both of these lines on the same graph, there is the possibility that they would intersect at a point, and that would mean that we have one solution. Okay, so that's a picture of what we would get if we got one solution. Okay, or another thing that could happen is that the two lines would be parallel to each other. Okay, and in that case there would be no solution, because there's no ordered pair that works in both of them. And the only other possibility that could happen would be that I have this line, and then I graph the other one and it's exactly the same line. And so that would be a case of infinite solutions. Okay, so those are the only three possible things that could happen when I graph two lines on the same plane. Okay, so in order for it to have a solution, it has to have an ordered pair that works. So example, is 5, 2 a solution for the system 3x plus 3y equals 16, and 3x minus 7y equals -1. Okay, well, if it's a solution, it has to make both of them true. So if I put 5 in for x and 2 in for y, does it make the first one true? No, because this is 15 plus 6, and that's definitely not equal to 16. So I know if it's not doesn't work in one, it's not a solution for the system. Okay, in order for it to be a solution, it must work in both equations. Okay, we also have what we call, let me give you a definition here, equivalent systems. And those are systems where the solution works in both systems. For example, if I have the system x equals 5 and y equals 3x, that's one system, and my second system is y minus x equals 10 and y plus x equals 20. Then if the ordered pair 5, 15 works in both systems, then we would say that they are equivalent systems. So if I plug in 5 for x and 15 for y, these are both true, so it works in that one. So it is 515 is a solution for that system, but is it a solution for this system also? Well, 15 minus 5 equals 10, that's correct. and 15 plus 5 equals 20. That's correct. So we would say that these two systems are equivalent systems. All right, well, how do we go about finding these numbers that work in the system? Well, there's actually 3 ways to do it. So, solving systems. Okay, one way is to graph. Okay, graph the system. Right, now graphing is not the best, and you'll see why in just a minute. So let's say I have the system 2x plus y equals 7 and x minus 2y equals 7. Okay, well, first thing I would do would be to put each one in slope-intercept form. So the first one would be y equals negative 2x plus 7, because I would subtract 2x from both sides. And the second one, let's say I would subtract x, and then divide by negative 2. And so the second one would be 1/2 x minus 7/2. And I think you can already start to see what the problem might be. Okay, so the first one says start at 7, 1, 2, 3, 4, 5, 6, 7, and then go down 2 over 1. All right, and so that would give me this line here. Okay, the second one says start at negative 7/2, so 1, 2, 3 and a half, there's negative 7/2, then go up 1 over 2, so I'd have to go up to here and over 1, 2, then up the middle, whoops, over 1, 2, up to the middle over 1, 2. All right, now here is the intersection. Okay, what is that point? Well, we know we have to go over 1, 2, 3, 4, somewhere around 4, and then down about negative 1/2. Okay, and because I didn't use a ruler, I'm off here, but the actual real solution of this is 4 comma negative 1.5, or negative 3/2. Okay, so you can see that it's really hard to see that answer. So graphing is not the best way to find the solution. So what's the second way? I said there was 3. So number 2 is to solve by substitution. Okay, so for instance, if I have 2x plus 3y equals 13 and x minus y equals 9, okay, notice on this second equation that at least one of the variables doesn't have a coefficient. So this is a very, very good candidate for substitution. So what you do is you take one of the equations, so I'm going to take the yellow one, the one highlighted in yellow, and I'm going to solve it for x. So I'm going to add y to both sides. So I'm going to get x equals 9 plus y, or y plus 9. Right? Now, in place of this x, I'm going to write the 9 plus y. Okay, so I have 2 times 9 plus y plus 3y equals 13. Now I just solve the equation because I have an equation in one variable now. So I have 18 plus 5y equals 13. Add 18 to both sides. I'm sorry, subtract 18 from both sides. So I get 5y equals negative 5. divide by divide by 5. Whoops. So I get y equals -1. Now I take this up here, plug that in, and I get 8. So the ordered pair that works for this system is 8, -1, which if I did this by graphing, if I graphed these two equations, they would cross or intersect at the point 8, -1. Okay, so we would see that they would cross at that point. Okay? The third method for solving systems of equations is it's called different names. One is linear combination. Some people call it the addition method. Okay, so let's say that I have the system 3x plus 2y equals 4 and 2x minus 5y equals -29. Okay, that's my system, and I want to solve it by linear combination or the addition method. So the goal here is to take one of the variables and get the coefficient the same number but opposite signs. And I notice here that the y's are already opposite signs. So if I multiply this whole equation by a +5 and this whole equation by a +2, I get this. 15x plus 10y equals 20, and I get 4x minus 10y equals -58. Okay, now notice now if I add these two equations together, I get 19x. The y's add up to 0, so they disappear, equals -38. Then if I divide by 19, I get x equals -2. Okay, now where do I get the y? So now I take this -2 and I go back to either one of the equations, it doesn't matter which one, and plug the -2 in. So I have 3 times -2 plus 2y equals 4. So -6 plus 2y equals 4. Add 6 to both sides, so 2y equals 10. Divide both sides by 2, y equals 5. So the ordered pair is -2, 5. So this is the solution to the system, which means, again, remember that if I graph those two, if I graph these two equations, they're going to cross at the point -2, 5, right? So all of these represent the situation where if I graph them, the graphs are going to cross at some point. But remember I said that there's two other things that could happen. So how do you recognize those things? Well, first of all, we say that if a system has at least one solution, we say that it is consistent. Okay, so that's the situation where the graphs cross or the graphs are the same line. So both of those would be considered consistent. Okay. The other possibility is that there is no solution. So we would say that it's inconsistent. Okay, and that would be the situation if the lines, if we graph the two lines, they would be parallel lines. Well, how do we know? Okay, how do we know if we don't graph them and we use one of the other two methods for solving? Well, here's an example. let's say I have 2x minus y equals 7 and 4x minus 2y equals 9. And I'm going to go ahead and solve this one by linear combination, or the addition method. I forgot to say this is also called the elimination method. So I'm going to multiply this top equation by -2. So that's going to give me negative 4x plus 2y equals negative 14. And the second equation is not going to change. And notice what happens. This adds up to 0, this adds up to 0, so I have 0 on this side, and this is negative 5. Now, does this make sense? Is 0 equal to negative 5? No, it's not. It's nonsense. It doesn't make sense at all. So this is the case where it's no solution. Okay? So when the variables drop out and you get a statement that doesn't make sense, then it's no solution. In other words, the lines must have been parallel. Okay? The next example, let's say I have the system 3x minus 2y equals x plus 8, and I have y equals x minus 4. Well, this system is an excellent candidate for substitution method, okay? Because I can, in place of this y, I can substitute x minus 4, and then I can solve the equation. So I have 3x minus 2 times x minus 4 equals x plus 8. So that's 3x minus 2x plus 8 equals x plus 8. So this is going to be x plus 8 equals x plus 8. And if I continue all the way to the bitter end, I get a true statement. 8 does equal 8. Okay? So when the variables drop out and you get a true statement, something that does make sense, then the answer is infinite solutions. And that's the case, if I graphed it, that's the case where the lines would be the same line. Okay? And this one up here, remember, the lines would be parallel lines. Okay? All right, so that would be a picture of that.